Hello and welcome to this walkthrough video for my Edexcel Higher Paper 3 practice paper. This paper has been created using the key topics revision list that you can find on my website. For this first question we need to write 8.9 times 10 to the power negative 3 as an ordinary number. Since we have times 10 to the power negative 3, we're just going to divide 8.9 by 10 3 times. So we'll start with 8.9, we divide this by 10 once, a second time, and a third time. And that gives us this answer, 0.0089. For the second part of this question, I would just type this exactly as it is into your calculator, then press equals, and it should show you this number here. Now we need to give the answer to this one in standard form. So first of all, we need a number that's between 1 and 10. So for this one, we'll need 3.2. And then we're going to times this by a power of 10. And if we put that decimal point in between the 3 and the 2, we can see we need to times it by 10 once, twice, 3 times, 4 times, 5 times, and 6 times. So it's times 10 to the power 6. For the first part of this question, we need to expand some double brackets. So we need to multiply everything in the first bracket by everything in the second bracket. So we're going to start with x times x, which gives you x squared. Then we've got x times negative 7, negative 7x. And then 7 times x, so that's plus 7x. And finally 7 times negative 7, which is negative 49. Then we need to do some simplifying with the x terms. We've got negative 7x plus 7x, which gives you 0x. So the answer to this question is just x squared minus 49. For the second part of this question, we're going to solve a quadratic equation. If we look at this final term here and consider factor pairs, we can factorize this quadratic. So what numbers multiply to give you 36? Well, we've got 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Now we need to pick the pair here that adds together to give you 13, specifically negative 13, but that means we'll have some negative signs in our brackets. So the pair we're interested in here is 4 and 9. This tells us the brackets will be x subtract 4, x subtract 9, and this equals 0. Now to find the solutions to this, we take each of those brackets and set them equal to 0. So we've got x minus 4 equals 0. To solve this, just add 4 to both sides. On the left you get x, and on the right you get 4. Then do the same for the next bracket, so x minus 9 equals 0. Add 9 to both sides, you get x on the left, and 9 on the right. So there are two solutions to this quadratic equation. We've got x equals 4 and x equals 9. For the first part of this question, we need to find the highest common factor of 63 and 105. To do this, I'm going to write both of those numbers as a product of their prime factors. You can either do this by drawing out a factor tree, although most calculators can do this for you. If you press 63 and then press equals, your calculator will display the number 63. Then if you press shift, and then there'll be a button that says fact, this will prime factorize 63 for you. So it will show you that 63 is equal to 3 squared times 7. Then we do the same for 105, so press 105, then equals, then shift, then fact, and it says 105 is 3 times 5 times 7. Now looking at the 3 squared in the 63's prime factorization, I'm just going to rewrite this as 3 times 3. Then I'll draw a Venn diagram. The left circle will be for 63 and the right one for 105. Then we need to put the numbers from the prime factors into this Venn diagram. We have a 3 in both of them, so we can cross those 3's out and put 1 3 in the middle. And we also have a 7 in both of them, so if we cross out that 7 and put that in the middle, and there's nothing else left that matches, so we just need to put the single 3 here in the 63, and also the single 5 in the 105. Now to find the highest common factor, you just multiply the numbers in the middle of the Venn diagram here, so we just need to do 3 times 7, which is 21. For the second part of this question, we need to find the lowest common multiple of 48 and 80. To do this, we're also going to prime factorize these numbers using the calculator. So for 48, you get 2 to the 4 times 3, and for 80, you get 2 to the 4 times 5. And for both of these, I'm going to write those 2 to the 4s as 2 times 2 times 2 times 2. Then we draw the Venn diagram once again. So we've got one circle for 48 and one circle for 80. Then we're going to cross off all of those 2's that you can see in both of them there, and put all 4 of those in the middle. And then we've got a 3 left and a 5 left. Now to find the lowest common multiple, we actually need to multiply every number that's in the Venn diagram. So we've got the 3, times all of those 2's, and times 5. You can just type this into your calculator and it'll give you the answer 240. For the first part of this question, we've been asked to find the class interval that contains the median price. So the median is the middle number when you put the numbers in order. You can see from the question it says we've got 55 ties. So if we do 55 plus 1, we get 56. And then if you half this, 56 divided by 2 is 28. This tells us that the middle tie price will be the 28th price. So we just need to count down the frequency until we hit 28. Well, if we go to the first category, 0 to £10, there's 21 there already. Then if we include the next category, there's 8 more, which means we've hit 29 ties. So we've gone past the 28th tie, which is the one in the middle, so the median must be in this category. So the class interval containing the median is from 10 to 20, this one here, and we write that as our answer. For the second part of the question, we're told the shopkeeper orders 6 more ties and they're all priced at £9. This means they'll all fall into that first category from 0 to £10. So instead of there being 21 ties in there, we can remove that and replace it with 27. Now when we come to find the median, we've actually got a greater total number of ties. We had 55 before, but now we've got 6 more, so that's actually 61 ties. So when we try and locate the middle price, we're going to need to add 1 to this instead, which is 62, and then half this, which is 31. So the middle tie is now the 31st tie. So in the first group we have 27, and then if we add in the next group we've got 27 plus 8, which is 35. So we've gone past the 31st tie, so we're still in this category from 10 to 20. So to answer this question we do agree with the shopkeeper, so we'd put yes. The 31st, which is the middle value, is still in the same group. For the first part of this question we need to write down the coordinates of the turning point of the graph. The turning point is this point located right at the bottom of the graph here. You can see its coordinates are -1, -3. For the second part of the question we need to estimate the roots of the equation. The roots are where the graph crosses the x-axis, so this one here and this one here. If you read off those values you get about -2.7 and also +0.7. In this question we have a rectangle and we're told some information about the sides. AB is going to be increased by 12%, but BC is going to be reduced by X%. So since we know the length of AB, let's increase that by 12% first. AB is 320, and if we want to increase that by 12%, we can multiply it by 1.12. This gives you 358.4. And then we have BC and we're going to reduce that by X%, but we don't know what X is. Then we've been told the area of the resulting rectangle is 48,384. Well, if we know the area and we know the new length of AB, we could divide those to work out the new length of BC. So if we do 48,384 divided by this new length for AB, we'll find the new length for BC, which is 135. So BC is now 135. Now we've been asked to find the value of X, which is the percentage that BC was reduced by. So BC was originally 180 and now it's 135. So we can use the formula change over original times 100. So to work out the change, we just do the original one, which was 180, minus 135. And then we divide this by the original one, so it was originally 180, and then times that by 100. So it's change, divide by original, times 100. Just type this into your calculator and you get the answer 25%. In the first part of this question, we've been asked to work out the length of AO. Since AOD is a right angled triangle, we can use trigonometry to do this. So if we label the sides, OD is the hypotenuse, we've also got AD, which is the opposite, and AO, which is the adjacent. Now for this question we don't need the hypotenuse, so we'll lose that. This leaves us with the opposite and the adjacent, so we need to use tan. So we can write tan 77, which equals the opposite, which is 15, divide by the adjacent, the one we're trying to find. If you rearrange this, you'd end up with the adjacent equals 15, divide by tan 77, and if you type this straight into your calculator, and round to 3 decimal places like it asks in the question, you get 3.463. For the second part of this question, we need to work out the length of the arc ABC. To do this, we're going to use the formula theta over 360 times by pi times by the diameter. So we need to work out theta and the diameter. Let's start with theta. So theta is the angle for the sector. Let's mark this onto the diagram. You can see that's this red angle here. The whole angle around a point must be 360 degrees, so to get the red one, we can do 360 take away 77. So the angle for this sector is 283. Next we need the diameter. Well, in the previous part of the question we worked out AO, which is the radius of the circle, so the diameter will just be double this. So if we double the answer from the previous question, we end up with 6.926, and so on. Then we just type this straight into our calculator, and you get the answer 17.1, rounded to one decimal place, like it asked in the question. For the first part of this question, we need to work out how many lemon flavoured cakes Ryan needs to make. So you can see in the table that 4 people chose lemon, and you can also see earlier in the question he asked a sample of 12 of his neighbours. So the fraction of people that selected lemon from the sample is 4 over 12. So we just need to find 4/12 of the number of cakes that we're going to make. We're told the number of cakes we're going to make is 300, so we need to do 4/12 of 300. You can do this just by multiplying 4/12 and 300, and I'd use your calculator to do this, and it'll give you the answer 100. In the second part of the question, we're told that Ryan is going to spend £40 on all of the ingredients needed to make these cupcakes. He's also going to sell them at a price of 25p each, and we need to work out his percentage profit. So first of all, let's work out how much he sells all of these cakes for. Well, if there are 300 of them and they're 25p each, we can just do 300 times 25p, which is £75. Then we can use the formula we used in a previous question. So to work out the percentage profit, you do the change, divide by the original, times by 100. So if he sold all of the cakes for £75 and originally spent £40, the change is 75 take away 40. Then we can divide this by the original, he originally spent £40, and then times this by 100. If you type this into your calculator, you'll get 87.5%. In this question, we need to complete a table of values. You can see here we've been given some x values, and we need to work out the y values. To do this, we're just going to substitute the x ones into this formula here. So instead of x cubed plus 2x, we're going to use each of the numbers, -2, -1, and so on. So let's start with -2. So we need to do -2 cubed plus 2 lots of -2, and I would type this straight into your calculator, and you'll get the answer -12. So when x is -2, y is -12. Then we repeat this process, but instead use -1. So -1 cubed plus 2 lots of -1, which gives you -3. So when x is -1, y is -3. Then we just do this again with 0, and that gives you the value 0, and then with 1, and 1 gives you the value of 3, and finally 2, and 2 gives you the value of 12. Now we've completed this table, we can use it to draw the graph. So we're going to look at each of these pairs here as a coordinate. So we need to plot the point -2, -12, that goes here. Then -1, -3, that goes here. Then 0, 0, that goes here. Then 1, 3, that goes here. And finally 2, 12, and that goes here. Then we join these up with a nice smooth curve, something that looks like this. For this question, we're going to use the stem and leaf diagram to draw a box plot. Let's start by finding the lowest value and the greatest value in the stem and leaf diagram. You can see those quite clearly, there's 18 for the lowest and 51 for the greatest. This means we need to draw a vertical line at 18 and 51. So let's do that now. Then we move on to the lower quartile, the upper quartile, and the median. If you count up the number of leaves in the diagram, you find that there are 19. This tells you that there are a total of 19 goats. Then if we add 1 to this, 19 plus 1 is 20, we can just divide this by 2 and divide this by 4 to find the median and the lower quartile. So if you divide it by 2 first of all, 20 divided by 2 gives you 10, so the 10th value is the median. If you divide it by 4 instead, you'll get 5, so the 5th value is the lower quartile. Then if you take this 5 and multiply it by 3, you find the 15th value is the upper quartile. So we just need to locate the 5th, the 10th, and the 15th value in the stem and leaf diagram. If you count through in order, you'll find the 5th number here is this one, so that's 27. The 10th one is this one, so 31, and the 15th one is this one, so 33. We can then plot vertical lines at each of those, and then join out the box and complete the box plot. In this question, we're going to enlarge this shape. We've been given the centre of enlargement negative 2, 1. So the first thing we're going to do is mark this onto the coordinate grid. We've been told the scale factor is negative 1.5. So let's pick a point on shape A, I'm going to go for this one, and draw a line from that point through the centre of enlargement. Now since this enlargement is negative, we're going to go the opposite way to usual, we're going to go past the centre of enlargement. The question is, how far do we go? Well, to get from our point on the shape to the centre of enlargement, you go across 2 squares and down 2 squares. Since we've got a scale factor of negative 1.5, we need to do this once more, and then a half again. So if we go across 2 and down 2, and then across a half of that, so across 1 and down 1, we end up at this point here. Then we're going to do the same process with the other point, so let's use this one here. So we draw a line from this point through the centre of enlargement. For this one, you can see you'll go across 1 square and down 4 squares. So we need to do this once more and then half again. So from the centre of enlargement, if we go across 1 and down 4, and then across a half and down 2. And that puts us right at the bottom of the diagram here. Then we do the same with the final point, so this one here. You can see this one is just 3 squares down. So we do that once more, so 3 squares down. And then half of that, half of 3 is 1.5. So we go another 1.5 squares down and we end up here. If you connect up these points, you can see the final shape looks like this. And we've been asked to label it B. In this question, we need to try and find a single transformation where exactly 2 of the points are invariant. If you want 2 of the points to be invariant, you need to pick a reflection. So the simplest one to spot is a reflection in this line here. Since the points A and B are directly on the line, this means when we reflect them, they won't move, and so they're invariant. So for this one, we could say it's a reflection, and then in the line, x equals 1. For the second part of the question, we need to find another one. Now there are 2 more possibilities left. I would recommend using this line here. I would recommend using this line here, so the one where B and C are on it. Now the equation of that line is y equals minus x, so we could say it's a reflection in the line y equals minus x. Now if you really wanted to, there's a more complicated line you could use, which is this one here, so the line that has A and C on it. And if you're going to describe that one, you'd also say it's a reflection, but the equation of the line is y equals negative 3x plus 4. Now any of the answers I've given to A or B here will be valid for either question, so as long as you put one of these reflections for each of the questions, you'll get all the marks. To do this question, we're going to take each of these recurring decimals and turn them into fractions. So let's start with 0.53 recurring. We say x equals 0.53333 and so on. Then if we multiply this by 10, we'll get 10x, which is equal to 5.333 and so on. Now at the moment, not every single digit after the decimal point lines up, so we're going to multiply by 10 again, and we get 100x, which equals 53.3 recurring. Now if you look at the one for 100x and 10x, you can see that every single digit after this decimal point lines up perfectly, they're all 3s. So if we remove the one with x and subtract these two, 100x take away 10x is 90x, and 53 take away 5 is 48. Then all of those numbers after the decimal point will cancel, since 3 take away 3 is 0. Now we can find x by dividing both sides by 90, and you get x equals 48 divided by 90. Now you could simplify this, but I'm going to advise leaving it, and you'll see why in a moment. We're going to do the same process with the 0.16 recurring. So x equals 0.16 recurring, multiply it by 10 to get 10x. This doesn't line up, so multiply it by 10 again, and you get 16.6 recurring, which does line up. You can see all of these are 6s. So if we subtract the 10x from 100x, we get 90x again, and 16 take away 1 is 15. Then divide both sides by 90, and you get 15 over 90. So we've managed to convert both of these recurring decimals into fractions. So the first one was 48 over 90, and the second one 15 over 90. And we need to divide these. In order to divide them, we're going to change it to a multiply and take the reciprocal of the second fraction. You can then cancel these 90s, which is why I suggested not simplifying them earlier, and you just get 48 over 15. You can divide both of those by 3, so when you simplify it, you get 16 over 5, and then if you convert that into a mixed number, you get 3 1/5, which is what we needed to show. For the first part of this question, we need to write this quadratic expression in the completed square form. First of all, we look at the coefficient of x here, which is a positive 6, and we half that, so half of positive 6 is positive 3. This tells us the number that needs to go in the bracket, the value of a. So it's x plus 3 all squared. Then we look at this a term here, which is plus 3, square it and subtract it. So if you square 3, you get 9, so we subtract 9. What this means is this expression that we've written here will be exactly equal to x squared plus 6x, since the 9 that we would have got from expanding the bracket will be cancelled. But we don't want x squared plus 6x, we want x squared plus 6x plus 11, so we also need to add 11. All that's left to do now is simplify these two terms here. Negative 9 plus 11 is 2, so we end up with x plus 3 all squared plus 2. For the second part of the question, we're looking for the coordinates of a turning point. Notice the equation of the graph here matches the expression we were given in part A. This means we've already completed the square, so that completed square form might be useful. To find the coordinates of the turning point, you simply take the opposite sign of the number that's inside the brackets, our a value, which was 3, so the opposite sign of that is negative 3, and then we just use the value that we got for b as our y coordinate, so this one here, so it's a positive 2. So the turning point is at negative 3, 2. For the first part of this question, we need to work out an estimate for the acceleration of the car when t equals 10. When you have a speed-time graph, the acceleration is the gradient of the graph. Since this graph is not a straight line, it's curved, we're going to need to draw a tangent to find its gradient. So we'll go to the point where time equals 10 and draw a tangent there. Then we just need to work out the gradient of this tangent, so I'm going to draw a gradient triangle, something like this, and then we need to work out the change in y and the change in x to find that gradient. So the change in x goes from 10 to 30, that's a change of 20, and the change in y goes from 10 to 62, that's a change of 52. Then we do the change in y divided by the change in x, so 52 divided by 20. Just type this into your calculator and you'll get a gradient, which is the acceleration of 2.6. Now you may not get exactly 2.6, it really depends on how you drew your tangent, so there'll be some flexibility in your answers for this question. For the second part of this question, we need to work out an estimate for the distance that the car travels in the first 30 seconds of the journey, and we're told to use 3 strips of equal width. So if we've got 30 seconds and we're going to split that into 3 strips, each of those strips will be a 10-second strip. So if we go at 10-second intervals across the time axis and draw some vertical lines up to the graph, you can now clearly see the 3 strips we're going to use. Now if we connect up all of the top points, we get a triangle here and then 2 trapeziums. So we need to work out the area of these 3 shapes. Let's start with a triangle. To work out the area of a triangle, you do half times the base times the height. So that would be 0.5 times the base, which is 10, and times the height, which is also 10. This gives you 50. Then we move on to the trapezium. This is 1/2 multiplied by the sum of the parallel sides. Now the parallel sides are actually the vertical lines here, so that's 10 and 52, and then we multiply it by the height, and this might be slightly confusing, but since the trapezium's on its side, the height is actually the horizontal distance, so 10. Type this into your calculator and you get 310. If we then repeat this with the final trapezium, we do 1/2 times the sum of the parallel sides, this time it's 52 and 66, and times this by the height, which is again 10. Type this into your calculator and you get 590. So the distance travelled would be the area of all of these 3 shapes, so we just add together those, and you get the answer, 950 metres. In this question, we're going to try and find the area of triangle ABD, but we need to find the length of the line BD first, so we're going to focus on this blue triangle here. We can find the length of BD using the cosine rule, so if we label the sides of the triangle like this, making sure that BD, the missing one, is A, then we can also label the angles like this. So the opposite angle to each side is the same letter, but a capital letter. Then we can use the cosine rule, so a squared equals b squared plus c squared minus 2bc cos a. So a squared, we don't know, we'll just leave that as a squared. B we do know though, and c we do know, so that's 8 squared plus 6 squared, and minus 2 lots of 8 times 6, and times cos of a, and we've got a as 130, so it's cos of 130. If you type all of the right hand side into your calculator, you find that a squared is equal to this number here, and then to find a we square root both sides, which gives us a equals the square root of this number. And if you type that into your calculator, you'll get this number here. So we found the length of BD, which we called a in this case, at 12.7 and so on. So let's add this to our diagram. We're now ready to find the area of this triangle here. We're going to use the rule half AB sine C. A and B are the sides either side of the angle you're going to use. So we could say that 14 is the A, 12.7 and so on is the B, and C is the angle in between them. So we just do 1/2 times a, which is 14, times b, which is 12.7, and so on, and times sine of 74. Now for the 12.7, you need to make sure you use the number that was on your calculator screen, not a rounded number of 12.7. So make sure the full number 12.71643073 and so on is on your calculator screen. If you type all of that into your calculator, you'll get this number here, rounded to one decimal place at 85.6. Here we have an equation to solve. We're going to start by writing the left-hand side as a single fraction over a common denominator. Looking at the denominators of the fractions we have, we've got x minus 1, x plus 1. So the common denominator will be those two multiplied together. On the left fraction, I already had an x minus 1, but I've multiplied the bottom by x plus 1, so I need to multiply the top by x plus 1 as well. Since it's just 1 on the top, it's 1 lot of x plus 1, which is x plus 1. On the right fraction though, I already had an x plus 1, and I've multiplied by x minus 1. So the 2 that's on the top of that fraction will need to be multiplied by x minus 1 as well. And then this equals the right hand side of 3 over 2. Since these two fractions have a common denominator, we can write them as one single fraction like this. And this equals 3 over 2. Next, we're going to remove the fraction by multiplying by this denominator. On the left hand side, it will cancel, and then on the right hand side, we'll multiply it by 3 over 2. So we end up with this. Now we've got some expanding and simplifying to do. On the left hand side, we've got x plus 1, and then we need to expand out this bracket. Negative 2 times x is negative 2x, but you need to be really careful here. Negative 2 times negative 1 is a positive 2. And then on the right hand side, we've got this. If you simplify the left hand side, you've got x take away 2x, which is negative x, and 1 add 2, which is 3, which we could write as 3 take away x. Now we need to look at the right hand side. You can see we've got a divide by 2 here. We can cancel that by multiplying both sides by 2. If you multiply the left side by 2, we get 6 minus 2x, and if you multiply the right side by 2, that'll cancel out that divide by 2, so you've just got 3 there. Next, we'll leave the left hand side as it is, and look at these double brackets here. So if you expand it out, x minus 1, x plus 1, you'll get x squared, plus x, minus x, which will cancel, and then minus 1. So you just get 3 dots of x squared minus 1. If you expand that, that gives you 3 times x squared, which is 3x squared, and 3 times 1, which is negative 3. So this is starting to look like a quadratic equation. We just need all of the terms on the same side, and I'm going to go for the right hand side since it has a positive x squared there. To do this, I'm going to subtract 6 from both sides, that'll cancel that 6 on the left, and also add 2x to both sides, that'll cancel the negative 2x on the left. This will give you 0 equals, then we've got 3x squared, then we added 2x, remember, so plus 2x, and then we also took away 6, but there's a negative 3 on the right, so negative 3 take away 6 is negative 9. So this leaves us with a quadratic equation to solve. Now there's a big clue in the question. It says give your answer to 3 significant figures. This tells us we need to use the quadratic formula. So a is the coefficient of x squared, that's 3, b is the coefficient of x, that's 2, and c is this constant term, which is negative 9. Now you'll find the quadratic formula for this exam at the front of your paper. We just need to substitute the values of a, b and c into it. So we've got x equals, then it's negative b, so negative b is negative 2, plus or minus the square root of, then it says b squared, and we've got b as 2, so 2 squared, minus 4, times a, which we have as 3, times c, which we have as negative 9, and then divide all of this by 2a, and since we have a as 3, 2 lots of 3 is 6. Then what you can do is type this straight into your calculator, but I like to do this in stages, so I like to type in what's inside the square root first. If you do 2 squared minus 4 times 3 times negative 9, you end up with 112. So I like to write this as x equals negative 2 plus or minus the square root of 112 over 6. Next we need to separate this into its two solutions. We're going to write it out again, but once with the plus and once with the minus. So we have x equals negative 2 plus square root 112 over 6, but also x equals negative 2 subtract square root 112 over 6. You can now type both of these into your calculator and round it to 3 significant figures like it asks in the question, and you'll get the answers x equals 1.43 and x equals negative 2.10. In this question, we've been given a formula to work out the height of a rocket n plus 1 minutes after it's been launched. We've been told the rocket is launched from the ground at 0 kilometers. This tells us the first value, which we could call h0, is 0. Then we can work out the height of the rocket for each minute after this by substituting the previous value into that formula. So let's work out the height of the rocket after 1 minute, which we could call h1. To work this out, we're going to substitute h0 into the formula. So it says k times hn, and that's our 0, so k times 0, and then plus 8. Anything times 0 is just 0, and then if you add 8, you get 8, so the value of h1 is 8. Now we can use this value of h1 to get h2. So the height after 2 minutes will be k times the previous one, which is 8, and then plus 8. K times 8 is just 8k, so we could write this as h2 equals 8k plus 8. Now we actually know the value of h2, we're told it in the question. It says after 2 minutes the height of the rocket is 20.4. So we can replace that h2 with 20.4, and then we have an equation that we could solve to find k. If you subtract 8 from both sides, you get 12.4 equals 8k, and then divide both sides by 8, you'll get a k value of 1.55. In the question, we've been asked to find the average speed of the rocket for the first 4 minutes of the journey, so we need to keep this going until we get to h4. Let's go for h3 next. So h3 will equal k times the previous value. Now we know what k is, that's 1.55, and the previous height is 20.4, and then plus 8. Type this into your calculator and you get this number here. Then we can get h4 by doing k 1.55 times this previous value, and then plus 8, and that gives you this. So we've now found the height of the rocket after 4 minutes, it's 69.411 kilometers. The question has asked us to give the answer in kilometers per hour though, but we haven't got kilometers per hour, we've got kilometers per minute. So the rocket has travelled 69.411 kilometers in 4 minutes. We need to know how far it will travel in 1 hour. Now 4 minutes will fit into 1 hour of 60 minutes 15 times. So if you just multiply this by 15, you get 69.411 times 15, which is 1041.165. This tells us the rocket will travel 1041.165 kilometers in 60 minutes, also known as 1 hour. So this is the speed, 1041.165 kilometers per hour. Pretty fast. For this question, we've got an algebraic proof. It says we've got two consecutive cube numbers. So let's say one of our cube numbers is going to be n cubed, the next one must be n plus 1 cubed, since they're consecutive. It also says we want the difference of these two numbers, so we're going to need to subtract them. If we're going to find the difference, we'll do the biggest one of those, which will be n plus 1 cubed, subtract the smaller one, which is n cubed, and we need to show this is always one more than a multiple of 3. So let's expand this out. n plus 1 all cubed will be n plus 1 times n plus 1 times n plus 1, and then we've also got minus n cubed on the end. Here we have a triple bracket to expand. So we're going to expand the first two of these brackets first, just n plus 1 times n plus 1. You can expand that by doing n times n, which is n squared, n times 1, which is n, and then 1 times n, which is also n, so that's 2n, and then 1 times 1, which is 1, and that's the double bracket expanded. But we've also got this third bracket here and the minus n cubed on the end. So now we're going to multiply these two brackets together. We need to multiply everything in the first bracket by everything in the second bracket. We're going to start with n squared times n, which is n cubed, then n squared times 1, which is plus n squared. Then we'll move on to this 2n, so 2n times n, which is 2n squared, and 2n times 1, which is 2n. And then onto the 1, we've got 1 times n, which is n, and 1 times 1, which is 1. And don't forget this minus n cubed on the end. Now we need to simplify this. You can see at either end we've got an n cubed, but we've got n cubed take away n cubed, which means they'll actually cancel out to give 0. Then if we look at the n squared terms, we've got n squared plus 2n squared, that's 3n squared, and then 2n plus n, which is plus 3n, and then also a plus 1. The question said we need to show this is always one more than a multiple of 3. Well, you should notice two of these terms have a 3 in front of them, and then we've also got this plus 1 at the end, which is the one more bit. So if we factorise 3 out of those first two terms, we'll get 3 lots of n squared plus n, and then plus 1. Now, if we could factorise 3 out of those first two terms, this bit here must be a multiple of 3. And then if you add 1 to it, it's going to be one more than a multiple of 3. So we've now finished the proof. To approach a question like this, I'm going to draw out a table since there's lots of different bits of information. I'm going to put all of the liquids across the top, so we've got liquid A, liquid B, and liquid C, and then going down the side, I'm going to put the density, the mass, and the volume. Now we're told the ratio of the densities of liquid A and B in the question, that's 4:3. Now whilst we don't know the actual numbers for the densities, we do know they're in this ratio, so we could pick any pair of numbers as long as they simplify to give this ratio. It would be simplest to just pick 4 and 3. We can do a similar thing with the ratio for the masses of 5 and 2, so let's just say the mass of A is 5 and the mass of B is 2. Now we need to recall the formula for density. Density equals mass divided by volume, which if you rearrange to make volume the subject, gives you volume equals mass divided by density. So to work out the volume of any of these liquids, we do its mass divided by its density. Now we said that the mass of liquid A was going to be 5 and the density of it was going to be 4. So its volume will be 5 divided by 4, or 5/4. If you do the same thing with B, the mass is 2, the density is 3, so its volume must be 2/3. Next we're going to use this information here. 3 cans of liquid B are mixed with 1 can of liquid A to form liquid C. Now if you're going to mix 3 of B with 1 of A, you're going to need 3 of B's mass and 1 of A's mass. So if we take the mass of 1 can of A, which is 5, and add to that 3 lots of the mass of B, so 3 times 2, you end up with 11. This tells us the total mass of liquid C would be 11. Now we can also apply this to the volume. If you take 3 lots of liquid B and 1 lot of liquid A, you just need 3 lots of the volume of liquid B and 1 lot of the volume of liquid A. So we'll take 5/4, 1 lot of can A, and we'll add to this 3 lots of the volume of can B. When you do 3 times 2/3, the 3's will cancel, so that's just 2. Now to add these together, you could either use a common denominator, we could rewrite that 2 as 8/4, or you could have just typed it into your calculator and it gives you 13/4. This tells you the volume of C will be 13/4. Now we can't use this same approach with densities, it doesn't work like that with density. To work out the density of liquid C, we need to use the formula density equals mass divided by volume. So we'll do the mass of C divided by the volume of C. So the density will be 11, which is the mass of C, divided by the volume of C, which is 13/4. We can change this into a multiply and take the reciprocal of the second fraction, so 11 times 4/13, which gives you 44/13. So we now know the density of liquid C, that's 44/13. We just need to complete the question by writing the ratio of the density of liquid A to the density of liquid C. So we had the density of liquid A as 4, and the density of liquid C we've just worked out is 44/13. We'll need to write this as a ratio in its simplest form. Let's multiply both sides of this by 13. 4 13s are 52, and on the right that'll cancel the 13 to give you 44. And to simplify this fully, you can divide both of these by 4, which gives you 13/11. Thank you for watching this video, I hope you found it useful. Here are some suggested grade boundaries, but remember we don't know the real grade boundaries until after the papers have been done. Check out the video I think you should watch next and subscribe so you don't miss out on future videos.